Hi, so today we're going to be doing another problem, question number 4. And this problem wants us to find the values of a and b so that f of x is continuous. So this problem has a few steps, so we're going to take this pretty slowly. So what we want to do with these problems, the first thing that's really important is to notice everything we have up here. So to find these values, we had to take the left and right limits of these numbers. So we have a 1 and we have the number 2. And when we take these values, we have to make sure that we're using the right equation. So I want to take the left limit of the number 1. This little negative sign after the 1 means the left. Similarly, if I wanted to do the right, I could write a positive. But for this first step, that's what we're doing, is the left limit. Now, when taking the left limit, that doesn't mean we're taking a negative 1, but that does mean we're taking all the values to the left of negative 1. So if you look at a graph, we have the number 1 plotted right here. We want to do it for all of these values coming in from the left. So we have to make sure we find the right equation to use. So it means we have to find the right inequality. So when we're using values on the left of negative 1, that means we find values that are less than negative 1. So that would be our first inequality in our first equation. So I'm going to rewrite that equation. Now we can't just plug in the number 1, because if we plug in 1 on the bottom, we'll get a 0, and that doesn't exist. So we're going to have to find a different solution, and that means the only thing we can do at this point is to break this apart. So we have an x minus 1 and an x plus 1. And I'm wondering where I got that from. That is this, just written in a different way. And our denominator will stay the same. Now, if you'll notice, we have two x minus 1s, and we can go ahead and cancel them out. So that leaves us with the limit of x approaches 1 from the left, and we just have ourselves an x plus 1. And at this point, obviously, there is no more simplification. So we will go ahead and plug in our 1. And again, remember, it's not a negative 1. It's just 1 from the left, so it's just the number 1. So we plug it in. We don't rewrite that because we're already plugging in the value in. And obviously equals the number 2. So go ahead and box that off so you remember. So then we took the left limit of number 1. Now we need to take the right limit. Now if you look at our inequalities up here, obviously the first inequality, that won't work because it's numbers, all values that are less than number 1. But if we look at the second one, we have our x value is greater than or equal to number 1. So we're going to go ahead and use the second equation. So we're going to label this step number 2, and our equation is ax squared minus bx plus 3, and we need the right limit of that. That's the 1. Now in this case, since we're not in danger of there being a 0 in the denominator or any other things that might prevent us from just plugging in initially, because we have a polynomial right here, so we can just go ahead and plug in our values. Remember, we're plugging it into the x, not the a or the b. So we're going to go ahead and plug a times 1 squared minus b times 1 plus 3. And that will go ahead and give us a squared minus b plus 3. I miswrote that. That is just an a, because that the squared is only, it is distributed with this 1. So, not a squared, just a, because we did 1 times 1, that equals 1, and then 1 times a is just a. So go ahead and box off this answer because it will become important later on. And the next thing we're going to do, moving on to our other number, which is the number 2. So we need to take the left and the right. So we're going to start off the left. And if you look at the middle inequality right there, we have the x is less than the number 2. So taking all the numbers from the left, that means all the numbers below it, we'll use the second equation again. Then this time, we'll be plugging in the number 2. So the limit as x approaches 2 from the left. So we have a as 2 squared minus b times 2 plus 3. So 2 squared is 4, so we have 4a minus 2b plus 3. Gonna box off that answer. And then finally, for the limit part, we will do the limit. X approaches 2 from the right, which as you can see above here is the bottom equation. We go ahead and plug the number 2 into that. So we have 2x minus a plus b. And we're going to go ahead and plug in our number 2. So 2 is 2 minus a plus b. So we have 4 minus a plus b. Okay. Now at this point, this is an important step to remember. That we remember we took the limit, the left and the right limit of number 1 and number 2. So at this point, we need to combine these equations. So we're going to go ahead and write that as step number 5. So we set them equal to each other. So we're going to take our equation from the right limit of number 1, so a minus b plus 3, set that equal to the 2 we got from the left-hand limit of number 1. And at that point, we just combine like terms. So a minus b equals -1. Step number 6, we have to combine the equations for the left and right limit for number 2. So for that, we have for a minus 2b plus 3 equals 4 minus a plus b. And again, we're just combining like terms. So I'm going to add this a plus a, 5a minus 2b plus 3 equals 4 plus b. I'm going to subtract b. 5a Okay, at this point, we are combining like terms, so we have our 5a, so we have -2 minus 1 minus 3 plus 3 equals 4. Subtract 3, 5a minus 3b equals 1. Have our second equation there. At this point, we need to solve for values a and b. So we're going to go ahead and set number 7, these equations, on top of each other. A minus b, b equals -1. So you could either solve for a or solve for b. In this instance, I'm going to solve for b. And to cancel out the b, as you can see, we have 3b, -3b, and negative b. So that means we have to multiply the whole bottom equation by negative 3. And that will cancel out the negatives. Well, cancel out the negative for the b so that we're able to cancel out those values. So we rewrite the top, 5a minus 3b equals 1. So we have negative 3a plus 3b equals 3. Now we're going to go ahead and just simplify it through. So we have a 5 minus 3, 2a. Cancel these out, equals 4. Divide this, divide that. A equals the number 2. That is one of our solutions, but now we need to find b. Not done just yet. So we can go ahead and plug that in to one of the equations. I'm going to use the 5a equation, so step number 8. 5 times 2 minus 3b equals 1. So 10 minus 3b equals 1. Minus 10 minus 10. 3b minus 9 divided by negative 3 divided by negative 3. B equals 3. So there we have our two values. A equals 2, b equals 3. Here are all the steps.